Hello students, we are going to study about filling of the orbitals of the atom. Okay, so here we will be studying the Aufbau Principle, okay, Pauli exclusion principle, Hund's rule, electronic configuration. Okay, so we will be ending our chapter today. Okay, so first of all, energy changes. Okay, energies of the same energies of the orbitals of the same subshell, what happens? It decreases with the increase in atomic number. For example, okay, if we are taking of what 1s of this 1s, or you can take a 2s of hydrogen, 2s of water, sodium, 2s of lithium, 2s of sodium, 2s of potassium. What happens in this? The energy, these orbitals, in these orbitals, what happens in the same subshell, what happens? It decreases. So it goes on what? Decreasing as the atomic number increases. This is for what? Hydrogen. This is for what? Lithium. This is for sodium. This is for potassium. And you can see over here what happens in this. The energy is going decreasing. Okay, now next, coming to the Aufbau principle. Okay, Aufbau principle, he has arranged what? According to the n plus L rule only, which we have studied in the previous section. Okay, he arranged the electrons in the ground state according to the increasing energy levels, which we found the results by what? N plus L. Okay, here we had found what? 1s. What did we find? What was there? This N was what? 1. L was what? 0. It came what? 1. Isn't it? Then second, 2 plus 0. 2. 2 plus 1. 3. You can see here it is arranged accordingly. 1s, okay, then 2s, and then you can see what? 2p and 3s together. Why it came? Because here we have calculated for this p. Now let us calculate for 3s. 3 plus 0, it was 3. You can see they are having the same value of what? 3n plus L. Getting. Likewise, when you see for 3p and 4s, okay, 3p it becomes 3 plus 1, 4, and 4s become 4 plus 0, and that is 4, same value, isn't it? So, you can see over when they are in the same line, they are having the same energy value. Here you can see 3, here you can see 4, likewise 5, 6, 7, it goes on, and accordingly Aufbau arrange the electrons, okay, according to the what? The increasing energy levels. Okay, and this we will be taking in account in what? Doing the electronic configuration right now after some time. Okay. Now, Pauli's exclusion principle. What does Pauli say about his principle? He said that no orbital can have the same set of 4 quantum numbers. Means what? Suppose if this is what for S can have 2 electrons, okay, P has got 3 orbitals, okay. He said what? You all know that orbital can consist of only 2 electrons, okay. So he said that none of the orbital consists of electrons having same set of 4 quantum numbers. So those 4 quantum numbers were what? Come on, let us recollect. Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So when we talk about the principal quantum number, azimuthal quantum number and magnetic quantum number, it can be same, but here there is a difference of what? The spin quantum number. If one electron is in the clockwise direction, the other one will be in the anti-clockwise direction. Likewise, it will be filled, and you can see here there is a difference in the spin quantum number. So we can also say, or Pauli's exclusion principle also explains that yes, the electrons present in the orbital will have different spin quantum number. Okay, one will be clockwise, other will be anti-clockwise. twice. Next rule is Hund's rule. Okay. Now Hund's rule of multiplicity, it is said actually. Okay. He said what? When the electrons are arranged in the orbitals, what happens? First it is singly arranged and then only pairing starts. Like, you can see this is the S subshell, this is what? The P having 3 orbitals. Okay. So here in S, suppose if it is hydrogen, okay, consisting of only what? 1 electron. Okay. So you write in this manner. Okay. Then helium consisting of 2 electrons. So what happened? This is the S. First it will be filled. So now 2 electrons accommodated. Coming to lithium, consisting of 3 electrons. Isn't it? Got it? Now beryllium 4. Okay. So what happens? This, we will not be this here. If 4 electrons are present, it will not come here. Okay. It will come here. Getting? Now let us study electronic configuration. Okay, in this what the electrons are arranged in the different orbitals according to the energy level. Okay. Now here let us do some examples. It follows actually which rules? Aufbau Principle, Pauli's Exclusion Principle and Hund's rule. Okay. So let us start. Hydrogen consisting of only 1 electron, it becomes what? 1s1. Helium consisting of what? 2 electrons, it becomes 1s2. Lithium consisting of 3 electrons becomes 1s2 and 2s1, isn't it? Beryllium consisting of how many? 4 electrons, it becomes 1s2, okay, and 2s2, okay. Next for magnesium, okay, it consists of 12, so it becomes 1s2, 2s2, 2p6, okay, and 3s2. Count it, 10 plus 2, 12, okay. Likewise you will be going on. Okay. Now let us do it for iron also. You can do it. Come on, it is 26. Okay, 26. So Hawk's atomic number is what? 26. Let us fill the electrons. It becomes 1s2, 2s2, 2p6, 3s2, okay, 3p6, okay. And then while filling the electrons, how we are filling it? 4s2, okay, and 3d, how much it will be? 6. But it will be written, when you will write, it will be written as 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s2. Okay, getting? Now these are how we are filling the electrons. We are seeing that what? The electrons in the D are filled later. Okay, but there are exceptions for what? Chromium and copper. Okay, so when we are talking about chromium and copper, okay, chromium, the symbol is Cr, okay, and its atomic number is 24. Let us fill the electrons first in this. Here it becomes what? 1s2, 2s2, 2p6, 3s2, okay, then becomes 3p6, okay, 4s2, how much it became? 10, 12, 18, 19, 20, and here it will be what? 3d4. But this is wrong, okay. Here there is an exception. You will be filling 1s2, 2s2, 2p6, 3s2, 3p6 and what? 3d5 and 4s1. Here you have seen from the S, 1 electron has shifted to what? This 3d. Why it happens? Because D consists of how many orbitals? 5, isn't it? So if there are 4 in this, it is not stable. Okay. If it is having 5, it will be more stable because this D orbital will be what? Half filled. Okay, and if it is half filled, you can see the number of exchanges can be what? More. 4 exchanges can be there. But if only 4 are present, so how many will be there? Only 3 will be there. So for making it more stable, what happens? We write 3d5 and 4s1 in case of chromium. Now, so what happened when we write in this manner? It has now got what? The stability, because half filled and fully filled are more stable than incomplete filled d orbitals. Okay, so now next exception is of copper. So if we are talking about copper, okay, copper's atomic number is 29. Okay, so let us fill in this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, how much it became? 10, 12, 18, 20, 29 it is written. So here will be what? 3d9. So here it becomes wrong, because if it is fully filled it will be more stable. So we will be writing 1s2, 2s2, 2p6, 3s2, 3p6 and 3d10 and 4s1. Getting? And why? Because here the number of exchanges can be more. Stability means, more stability means number of exchanges of the orbitals more will be there. And as the result, when the number of exchanges increases, the stability increases. This is why we have the exception for copper and chromium. So this is end of the chapter. Okay, take care, good day.